Hello, my name is Pat Hoppy. I am a retired teacher and a co-author for two textbooks and experiments manuals here at McGraw-Hill. They are Digital Electronics Principles and Applications and Electronic Principles. During my 22 years at Gateway Technical College in Racine, Wisconsin, I was both their division chair for engineering technology and an instructor. I developed and taught their electrical engineering technology program. During this time, student retention was always one of my goals. Our students started their electronics courses in the first semester. They were in lab by their second week of class. Over the years, I saw that when a new student had a positive experience during their first lab experiment, they were more likely to return the following week. One of the things students struggled with was a solderless breadboard. Not understanding how to build circuits on it led to frustration for the students. To remedy that, I would spend time at the beginning of their first lab covering the layout of the solderless breadboard and how to use a schematic to successfully build a circuit on it. Without training, the students struggled. Here at McGraw-Hill, we have designed a solderless breadboard simulation that explores the layout and interconnectivity of the holes in the breadboard and the function of the center channel. In addition, the simulation presents a systematic approach to circuit construction on a solderless breadboard based on a schematic drawing. Using Connect, you can assign this simulation to your students prior to their first lab experiment. This saves the lab time for the actual experiment while still providing your students with the knowledge needed for a better lab experience. Here, under the Introduction tab, the Key Concepts section introduces the layout and function of the different areas of the solderless breadboard. An overview of the simulation is presented to the student. Lastly, a systematic approach to constructing a circuit based on its schematic is available for the student to review. Let's look at a brief overview of the simulation. At the bottom of the screen, the Methods tab contains all the instructions of each phase for the simulation. The students can look at this if they want to read ahead as to what they're going to be covering. The Reset tab allows the student to reset the current phase or the entire laboratory simulation if they would like to work through it again. In the My Notes area, the student can jot down any notes that they have. These notes are saved. They can also be printed. And lastly, in the Lab Data area, the students will enter and measure data. We will look at that when we move on to a later part of this simulation. In phase one, as the students click on each area of the board, the function and layout of that area is explained. Let's move to phase two. Now that the students have completed the overview of the breadboard in phase one, they'll use a digital multimeter to investigate which holes are electrically connected. This will support the theory just presented to them. The only two possible measurements are 0 ohms for electrically connected holes and infinity for non-electrically connected holes. The students record each measurement in the lab data area. The measured data will then be used to answer questions at the end of this phase. Let's take a look at how this works. We'll turn on the meter, attach our first test lead. We measure 0 ohms. We'll enter into the lab data area and record that as 0 ohms. Move our test lead to the next group of holes. Here we're measuring infinity. We will record that. Move our test lead again. Record infinity. And move the test lead one more time. Again, we measure infinity. Once I enter this in, I'll then be asked a question. The students will see what they've just entered in the lab data area, and then using that, they can answer the question. The same approach that we used for the holes in the working area will also be used to look at the holes in the bus areas. We'll measure the resistance between holes in the same bus and holes in adjacent buses. Again, once the measurements are done, they'll use those measured values to answer a question posed to them about what they just did. At this point in the simulation, the students will utilize what they've just learned to build a series circuit from a schematic provided. Each step in the circuit construction is listed on the right side of the screen. We have the students place a check mark next to the component on the schematic as they insert that component in the board. This will help them keep track of what's been done should they have to step away from the circuit build. When they finish the circuit, they'll be presented with a question on how the circuit was constructed. Let's see how this circuit is built. In addition to the series circuit, we also do a parallel circuit. If they attempt to put the resistor in the wrong holes, they are alerted and then given a chance to put it in the correct holes. Once they've finished, they will then be asked a question, it's answered, and then they're allowed to move on. We've done a series circuit, a parallel circuit. The last circuit to build is a series parallel circuit. We start out by giving them R3 already in place. We'll have them place R1 and R2. Apply the check marks. Then R4 and R5. Apply the check marks. They're asked a question about what they've done so far. If they answer the question wrong, they'll be given an opportunity to do it again. Once they have it done correctly, they'll move on. Our last step here is to apply our leads for the power supply. Once that's done, our check marks are put in place and they're asked another question. When the students have built the 3 circuits, they're asked a series of questions about how the various circuits were constructed. After the 5 questions have been answered by the student, they are shown the questions and associated answers that they had just completed. Along with the collected lab data. They are also informed that all of this is available to be printed or saved as a PDF. In addition, it is reported back to Connect that the student has completed this simulation, so you know that they've gone through this. By providing this Solderless Breadboard simulation to your students prior to their first lab experiment, they'll enter the lab with an understanding of how to use a solderless breadboard. In addition, they'll have experience at constructing a circuit from a schematic. This simulation saves the lab time for the actual lab experiment, while still providing your students with the knowledge needed for a better lab experience. Thank you.